Hi everyone, in this segment we are going to be discussing stereocenters. We're going to do an overview on stereocenters. Stereocenters are carbons at which the interchange of two groups will result in the creation of a new stereoisomer. There are three types of stereocenters that we need to think about. We have asymmetric centers, which are also called chiral carbons or chiral centers. We have the sp3 carbons of cycloalkanes and the sp2 carbons of what we call easy alkenes. Now, it's very important that we distinguish stereocenters from asymmetric centers. We'll talk a lot about asymmetric centers / chiral carbons, but it's very important that you understand there are other types of carbons at which we can see stereoisomerism, okay? And remember, the term stereo, the root word of that means 3D, so we're talking about 3D isomers. Now, I want to illustrate this for you real quick. When you look at something like this is what we call an asymmetric center. We'll get to that in another video. But the idea here is if I were to change two groups, interchange them, I would result in the creation of a new stereoisomer. These two compounds are stereoisomers. We will, in this video series, talk about why that is. Now, they are stereoisomers and we can classify them differently. We have this chiral carbon being designated as an S configuration, and this one is designated as an R configuration. And because I could switch two groups and create a new stereoisomer, those carbons are stereocenters. These two carbons are stereocenters because of that. All right, they are carbons at which the interchange of two groups results in the formation of a new stereoisomer. We'll be talking about each of these three types of stereocenters in the next couple videos.